Good morning everyone and welcome to my YouTube channel. So here today we are going to prove some sets that have to do with the subsets. So if we are told that C is a subset of D, then simplify if possible these following sets. So now our first one is very simple. We have our C intersection of D. First we need to understand what our C is a subset of D means. So C is a subset of D means C is found in. So this is the meaning of C is a subset of D. So now if you are asked for the first one, C intersection of D, they are asking you, what does C and D share in common? So you will realize since C is found inside D, what is the only thing in common is just C. So C intersection of D is equal to C. As simple as that. So that is how we go about that one. Let's move to our next one. Let's say we have our C complement union of D complement like that. So how do we solve this one? So this one is nothing difficult about this one as well. So if we have the same set, we have C is a subset of C complement union of D complement. So same approach. Now we know that from De Morgan's rule, so we are going to say by De Morgan's rule, what C complement union of D complement is equal to is just the same as C union changes into intersection of D, then we are going to put the complement like that. So now when you see this, they are telling you to say C intersection of D. So we already know to say C intersection of D, what do these share in common? Since C is found inside D, it means to say the only thing in common, intersection means both. It means to say it will be your C. Then outside we have a complement. That means that we have answered that one. So we have simplified that one. Let's look at our third one. For this other one, we have a C union of D complement. So looking at this, there is no way you can exclude, let's see, just looking at this set, D complement. You cannot exclude D complement because already D complement also includes the C itself. So D means everything here. So D complement means excludes everything including the C. So there is no way for you to simplify this. So your answer here will just be cannot be simplified. So cannot be simplified. So let's say we have this. So same approach here. So what are we going to do? So we have our C complement intersection of, what is our C union of D? What is in the bracket? So C union of D means we are combining what is in C and D. Now you will realize to say if you combine your C and D, it means to say you are just shading just D. So since C is found in D, the whole set of D compiles for C union of D. So that means to say we are going to say it will be D inside here, then we have the complement outside. So then from here we can say by De Morgan's rule, we can be able to change this and say C, then the intersection will change into union of D, then we are going to say complement like that. So now if we know to say our C is found inside D, it simply means to say our C is found inside D. It means to say the C union of D is just the set D itself. If you combine C and D, it's just D. So it will be D complement. So let's look at our last example. If this is what we have, let's say there was no complement there, we are going to use the same approach. So using the same approach, what we are going to have is so firstly we have our C complement, then we are going to say intersection. What is our C union D? So C combining with D is just D, so we can just put our D like that. So this is what we can have. So this can be written as beginning with D intersection of C complement. So when you see your C complement, it means that excluding C is shading everything that is a part of D that is not a part of C. So this can just be expressed as a set difference by saying D minus C. D minus C means members that are in D that are not in C, which can account for the intersection of D. So that's how we go about that. Thank you very much. If you enjoyed the video, kindly like, comment, and share for more. Subscribe if you are new.